Hello everyone, welcome to this session. In this session, I am going to solve another problem on viscosity. The problem is that a 400 diameter shaft is rotating at 200 rpm in a bearing of length 120 If the thickness of the oil film is 1.5 and the dynamic viscosity of the oil is zero point 0.7 Newton second per meter square, determine first one torque required overcoming friction in bearing. The torque required to overcome the friction in the bearing. Second, power utilization in overcoming viscous resistance. The power required to overcome that viscous resistance of the oil what is there. Assume a linear profile. Linearly, the friction is changing from the contact surface to the center. Moving to the problem, here the sketch is given for that problem arrangement. This is the bearing which is having the 120 mm length, in which the shaft is rotating at 200 rpm and its diameter is given 400 and between this bearing surface and the shaft surface there is a fluid for the lubrication is used in order to avoid the friction, and for that the oil whatever used, its thickness is given. There is a 1.5 thickness of the oil between the bearing surface and the shaft surface is there, and its viscosity, dynamic viscosity or only viscosity we can say, it is given. And what we need to find out here, the twisting moment of the shaft, the torque required to overcome that friction. Okay, that is whatever the viscosity is there, that is actually resistance force offered by the fluid for the movement of this shaft. And what torque, the what twisting moment of shaft, how much quantity it is required to overcome that resistance offered by that fluid. And second one, the what is the power required for overcoming that viscous force? The power required to overcome that resistance offered by the fluid. That power also we need to find out. Moving to the given data of the problem, diameter of the shaft D is given 400 that we can write 0.4 meter. The speed of the shaft Newton N equal to 200 rpm. Thickness of oil film, that is T equal to 1.5 1.5 into 10 raised to minus 3 meter. Length of the bearing L is given 120 0.12, and viscosity or a dynamic viscosity we can say mu is given 0.7 Newton second per meter square. Here first we'll take that is its rotational speed of the shaft is given. The revolutions per minute rpm, the rotational speed it is. First, we'll take the tangential velocity of the shaft or a linear velocity of the shaft, we can say, and that is u linear velocity. Any notation we can say. Take here the u is taken in this numerical. That's given by pi dn by 60 is the diameter of the shaft, and n is the its rotational speed divided by 60 because it is in revolutions per minute. The speed is in revolutions per minute. To take per second, the 60 is divided. Then the pi, the diameter 0.4 and multiplied with a speed 200 and divided by 60, it will give the 4.19 meter per second. To calculate the torque required to overcome the friction, the T, to take that one, we need to find out the shear stress, shear force, then the torque will get. Okay, for that, we'll use the Newton's law of viscosity. We know Newton's law of viscosity equation. There is a tau is equal to mu into du by dy. Tau is a shear stress, mu is a viscosity or dynamic viscosity, du is a change in velocity, dy is thickness. And where du is change of velocity u minus 0, 4.19 meter per second. The u is the velocity, initial velocity. If you take 0, it will give this velocity. Moving to next, dy is the thickness of the oil, whatever is there, T equal to 1.5 into 10 raised to minus 3 meter, it is given. Substituting all these values, the tau can be given as 0.7 multiplied with the 4.19 by 1.5 into 10 raised to minus 3. By taking this one, the shear stress we are going to get 1955.3 Newton per meter square. Then shear force, already we know that one. The shear force is given by shear stress multiplied with the area. How we got this equation means the shear stress we know. Shear stress is equal to shear force by area. The force per area. Then the force if you require the shear stress multiplied with the area. Okay, then that whatever we are going to get here, the tau is the shear stress, pi dl. The area what we need to take here, that is the surface area which is coming contact with the fluid. Okay, where the frictional or a resistance is acting. The pi d is the circumference of the diameter and L is the length for which that fluid is coming contact with the sap, that is multiplied with that one. We are going to get the pi dl is the surface area of the shaft within that bearing which is coming contact with the fluid. Then the shear stress, already we know that if you can substitute the pi diameter of the shaft, we know length of the that bearing where the fluid is coming contact with the shaft, that we know 120 mm, that is a 0.212 meter. From that the shear force we can find out 294.85 Newton. Hence viscous force can be given as, that is a shear force multiplied with a perpendicular distance. The torque can be given as the force multiplied by the perpendicular distance. Okay, that is the force multiplied with the half of the diameter. For always, for the shaft, if you take that one, the force multiplied with the half of the diameter. Or we can take the force multiplied with the radius, that will give the torque. And here the viscous torque, that is this is the shear force which is acting by the that fluid. Okay, multiplied with this radius, then we are going to get the 8.97 Newton meter as the viscous torque. This much torque is required to overcome the that resistance offered by the fluid. Then next point, what is there? We are going to find out there is a power utilized, power required for that one. The power can be given as P equal to T multiplied with a 2 pi n by 60 or 2 pi nt by 60. That is what in terms of we are going to get. The T is the torque in Newton meter. Then P we are going to substitute 2 pi n. There is a n we know 200 and 60 for the Newton per RPS. If you want to take that one, we are going to divide it. And by calculation of this one, we are going to get 1235 watt. Or that can be expressed as 1.235 kilowatt. And this much of power is initially required to overcome that whatever the resistance offered by the fluid is there, which is usually used for the that lubrication purpose. And later onwards, the other power, whatever the for the rotation, we need to use. Okay, further I am going to solve some more numericals and some videos on this one. Thanks for watching, and if you like, share, subscribe and comment.